So objectives for my talk, two things. Getting an overview of what's going on in the market of two-factor authentication solutions, what kind of solutions are out there that actually have been commercialized or maybe are available as open source, but that you can go and use, and look at those solutions from a sort of risk threat modeling perspective. What kind of problem are we actually trying to solve in our particular infrastructure? And are these solutions going to help us with that? So the agenda, when I first started thinking about this talk, I was like, oh yes, that's great. I'm going to do matrices of spreadsheets with criteria and products and little tick marks. And as I actually got closer to coming up with these slides, I was like, well, actually this is going to be totally boring and not very helpful. So what we're going to do is we're going to talk a little bit about motivation, so authentication in general, what are the issues with passwords, and then we're going to look at solutions and we're going to use them as examples for different questions that I think mostly from a security focus you want to ask yourself before you go and implement whatever solution you settle on in your infrastructure. And maybe there's some snake oil, maybe not, we'll see. So introduction, authentication factors. I think pretty much all of you are probably aware that traditionally we distinguish between different factors as either something you know, so typically passwords or pins, or something token-based, something we own, like a physical key that fits a lock, or these days, secure ID tokens and what have you. And biometrics, so the properties of a human, like fingerprints, iris patterns, or maybe the way you type on your keyboard is one that's being used in solutions. There's a fourth category that is being referred to as authentication these days a lot in products, which is called risk-based authentication, where we go and basically look at the behavioral pattern and the context of a user session. So things like, well, typically David logs into his banking application from IPs that are associated with the United States somewhere. He's traveling, like Texas, California, whatever, but all of a sudden, there's an authentication request coming from, I don't know, Asia. So maybe that's an indication that we have an unauthorized request there, maybe not. So you try to do like that kind of analysis. So why do we still use passwords? I like this quote I found in a paper that's maybe 2 years or so old. The continued domination of passwords over all other methods of end-user authentication is a major embarrassment to security researchers. I thought, well, it's sort of fitting. Passwords, they are ubiquitous, everybody uses them, everybody's used to using them, they're cheap to implement. That's what we have been doing. But they have some issues. So as security professionals, we worry about passwords being stolen, either on the server side, like a whole database of passwords and user IDs, but also by potentially malware on users' laptops and PCs, that keyboard loggers or something more advanced. Replay attacks, users don't choose good passwords, you can guess them, all those kind of things. Especially with the assumption that a lot of people make in information security management in their enterprises these days, that endpoints, laptops, PCs, smart, whatever, phones, cannot be effectively and efficiently secured against malware and exploitation. So we have to assume that adversaries are able to get to users' passwords by exploiting individual machines. So what are the issues with the existing alternatives? So when we talk memory-based, some people have come up with patterns, or maybe on your Android smartphone you log in by swiping your finger in specific patterns over the screen. So something you can remember. They all have essentially the same issue as passwords. Biometrics have their own issues. There's the whole topic of privacy and using your, personal identification marks for authentication. Some people say, well, really it's more identification and not authentication. They're really hard to work. A lot of solutions are easy to circumvent if there isn't a human standing next to the biometric reader, making sure that you don't cheat it. So, iPhone fingerprint sensor being an example was broken the day that they got the iPhone out that had it. Tokens, so hard tokens, soft tokens, smart tokens. Traditionally expensive because we used to use a lot of hard tokens. Difficult to replace, difficult for users to manage, can be stolen. So petty theft, I can steal that from your wallet, from your briefcase, rather than extracting a password out of your mind. Contexts, they help a lot in risk-based evaluation of sessions, but you can't really authenticate. You can't prove an identity just based on contexts, in my opinion. So not really a valid authentication factor by itself. So current industry trends, what are we doing to mitigate the issues we have with passwords? We use tokens, which are, harder to compromise, can be stolen though, and combine that with passwords, which are easy to compromise and steal, but physically you can't just extract them without somebody noticing what's going on. Obviously, there's other factor solutions in the running that we're going to look at, biometrics, context-based, we talked about that. One thing I want to remind you of, to just keep that in mind, and I'll come back to that in the end. User identification and authentication is really just a piece of the big puzzle of managing communities of users and identities, in particular in organizational infrastructures, managing access control, entitlements. So whatever solution you're looking at, you probably want to keep in mind that it needs to work with whatever you have on the back end for authorization, all those good stuff. So what we're going to do next is we're going to look at examples of solutions. And we're going to think a little bit about what we're actually trying to protect and how, and what the threats are. So typical, obviously there might be a difference in protecting like hundreds of thousands of accounts for like individual consumers that access a banking solution versus I have a couple hundred or thousands of corporate accounts, different data that is accumulated within the company than in individual user accounts, etc. All those thoughts, basically going back to typical risk assessment approaches and thinking about things. One thing I want to point out, in my slides I have a lot of screenshots, basically, examples. I looked around in the web a lot, what is out there, what are people selling. So there's a lot of examples of actual commercial products and open source products. By putting them on my slides, I'm using them as examples. I'm not endorsing anything in particular or discrediting anything in particular. We're just going to look at examples. So let's start thinking about criteria for multi-factor authentication solutions. I think the first question we need to ask is, are there actually more than one factor in the solution? So in my opinion, a password and a PIN matched together two separate secrets and then I enter them on the screen, it's still just one factor. It's knowledge-based authentication. There's nothing to be gained unless you are in a dual control situation where different people know different parts of the password. But other than that, that's not a multi-factor, not a two-factor authentication. How about passwords and private keys, crypto? Putting a certificate on my laptop, doing certificate-based authentication. For a while, that was being used, well, never really frequently, but you still see it around that certain websites for TLS, SSL expect the user to have a certificate that was issued to the user initially. Is that two factors combined with a password? Maybe yes or no, depends on, I think, what problem we're trying to solve. If we're assuming that our endpoint is compromised, then an adversary can get both to the password by observing keystrokes and to the certificate and private key by accessing it on the endpoint. So in that situation, probably it's not going to help us. In other situations, it might actually increase your your mitigation of whatever risk you're trying to mitigate. So things to think about. Who of you is familiar with MailChimp? It's a mass emailing solution. We use it for our local ISSA chapter, for our newsletter. Those guys actually put out a free solution that they call Alter Ego, and they themselves refer to it as 1.5 factor authentication. It works well if you use the app on a smartphone. It generates basically time-based one-time passwords, so something that's valid for 30 seconds or a minute. And then you log in, you use your laptop and log in with your password and then add the second factor from your smartphone. They call it 1.5 factors because there is a backdoor to that, and it's intentionally there that you can go and actually log into the Alter Ego portal on your PC, and that way, you do everything on your PC again, and if your PC is compromised, then it doesn't solve anything. So, works in some situations, not so well in others. A cool thing they do is actually for their commercial accounts, if you use their free 1.5 factor authentication solution, they give you a discount on their services. So I think that's just a cool thing. So something else, other example, a company called Swivel and their solution called PinSafe, they actually have a patent on that. Basically what they do is it's a human-computed challenge response protocol. So the user has a PIN, 4-digit PIN in their mind. Let's say it's 2478. And then every time you want to log on, the system sends you a challenge, like this random number here, randomly generated. And then in your brain, you are, well, okay, 2478, so the response to this challenge is 7143. And that way, what you type on your keyboard every time is something different every time. But then again, if you just display this little graphic in your web browser, and you assume your endpoint is compromised, is it going to help? If an attacker can get a hold of one of these challenges and your response to it, they can compute what your PIN is and use it. So I maintain that even in this situation, again, if you use different channels for the different factors, it might help a bit, but passwords and PINs, regardless of which protocol you use to transport them, are not different factors. Of course, that's an opinion. So let's talk a little bit more about communication channels. And sometimes you hear, oh, it's out of band authentication. What does that actually mean, and what does that gain us? What I did here, I hope you like my little drawing. We have a user here and his PC. And really what he wants to go and do is go to this website, buy fresh fish, and buy fish. Obviously, the password and username he enters on his laptop. For the credential, let's assume for now it's like a time-based, 30-second valid one-time password generate based on some cryptographic secrets. So there's an RFC out there, TOTP, that defines how to do that. And the differently colored arrows here are basically different information flows, scenarios that we can talk through in terms of how does the second factor, this one-time password, actually travel through the internet to the server that the user wants to get to. So a couple of thoughts here. There's obviously, this is a horse. So there's a Trojan horse on this computer. So user enters his credentials, including the one-time factor, and then the Trojan horse is like, oh, I'll take that, and he sends it to an adversary in the internet. And this adversary has 30 seconds, or be it 10 seconds now, where that token that the user entered is still valid. And so the adversary can use that to establish a valid session with the user's account here, impersonate the user, which might be all they need. Different scenario, let's assume the user uses the PC for the password, but sends the credential through the cell phone network. So he uses his smartphone. But unfortunately, he clicked on a link in his email that said, oh, fresh fish on sale, 10% off this weekend. And he just clicked on that and didn't notice that the URL for the website was buy fresh fish and not buy fresh fish. So a phishing website set up by our adversary that emulates the original website, looks the same, more or less. User enters his credentials. Regardless of the way these credentials travel, the adversary ends up with them again and can use them to establish a valid session. And again, in some situations, that might work for us, and that might be a good solution for us, but in others, we might be worried about this. The third one here is an interesting one that you see in a couple of particularly in smartphone-based solutions, which is that the user authenticates with his username and password at the service, and then the service sends a push notification to the smartphone and says, hey, are you really just trying to log on to my server? And the user can say, yes, that's me, or you can say, no, I'm traveling right now, what's going on? But that way, you have an out-of-band, so you have the original band here that the user and password travels through, and you have an out-of-band confirmation of that session established through a separate communication channel that an adversary has no easy way to intercept. Who can think of situations where that doesn't work? Exactly, yeah. So either they have your smartphone, or the user tries to log in to the Buy Fresh Fish site from his smartphone. And so it all goes back to one channel, and if the smartphone is compromised, which it's not an unrealistic assumption with Android, maybe Apple is a little bit better about it, but if all the authentication traffic originates from the smartphone itself, we are back to the question, well, do we need to worry whether the smartphone is compromised or not? Because if it is, then any adversary can get any authentication credentials that are based on the smartphone that way. Does that make sense? Any questions? Cool. So a little bit more about communication channels, just to give you some examples here. There's a solution called Duo that does pretty much what I just described as the last scenario there. They send you a push notification saying, hey, are you really in Austin right now? And did you just try to log into this or that service? And you can say yes or no. There's another service called Twofer that does something similar. Actually, UT, I think, just started using them for some student-facing applications. So there's solutions out there that do that. One thing you need to keep in mind when you implement a solution that I wanted to point out here as well is on the administrative side, on the backend side, the server side, if a solution offers multiple options. So for example, this Twofer solution has a backup. If you're offline and they can't send you a push notification, you can generate a traditional one-time password based on TOTP, based on a cryptographic key stored in your phone. Which messes with our different attack scenarios we talked about earlier. So you got to think about, can I, as the administrator, determine on the back end which credentials I accept or not from these different ones that the solution offers? Something to keep in mind. Another question is when to actually use the second factor. Or maybe you're using 3, I don't know, multi-factor. Typically, what most people are doing these days, they use it when the user establishes the session. User logs onto the service with a password and a second credential. What may make a lot more sense in certain scenarios, think about high value, high risk transactions, to just ask for that one-time password every time in an existing session the user tries to actually initiate a transaction. And so, you know, if an attacker was able to get one of these one-time passwords from the user somehow, then that only gets them that far, because every time you're trying to do something high value, the system will prompt you for your second factor. Another option, obviously, is doing it in this risk-based context analysis. We talked about that in the beginning. Basically, you just use username and password, but then whenever you see something in the context that's abnormal, then you say, hey, can you please give me your second factor as well? Can I please inconvenience you to do that? So different scenarios, you got to think about what actually addresses your risks. Another thing that goes back to the how do I centrally manage authentication question is how do you enroll tokens? How do you provision them, associate them with user IDs, those kind of questions. Most of you have probably seen these YubiKeys. They emulate a keyboard, a USB keyboard. So you plug them into your PC and they say, oh, I'm an HID device. And every time the user presses this button on the YubiKey, it'll spit out a one-time token via the keyboard interface. So as long as the user already has the cursor on the authentication field in whatever form, it'll be right there. Cool in some ways because it stores the cryptographic key that's used for that on a hardware token. Compromising the endpoint isn't going to get you those keys. And it's not even going to get you a token unless the user confirms and presses the button that right now he wants a token. So the user has control over that. Not so cool in other ways because they do have an NFC solution, but it doesn't work with all devices. Not every device has a USB port. However, what they do have, which is I thought pretty cool when I saw it, is they have this programming station where you can put 50 of these keys on a tablet at once, and it's connected to a workstation that basically loads 50 unique keys at once onto these individual YubiKeys and basically provisions them and associates them with user IDs for you. So, you know, at certain scales, you need to think about, does the solution scale with me? Crypto. That's one of my pet peeves. Not that I'm a good cryptographer, but as Martin Hellman actually was mentioning at the end of his keynote yesterday, he was talking about having backed up solutions for what you're using. And for, you know, maybe there being advances in how to factor large primes, and RSA is not going to be worth anything all of a sudden if somebody comes up with a way to do that. So in your solutions, I'm a proponent for making sure that there's options of different types of crypto algorithms. And almost all of our solutions are based on crypto these days, that you can fall back to if need be for whatever reason. Or maybe one of your master keys gets compromised or whatnot. You gotta think about what you know, basically incident preparedness. What are we gonna do? Do we have a plan in place? The other thing with crypto that you know, I like to point out is you wanna use reliable and trustworthy implementation and not go and try to implement AES yourself, because unless you are one of the very few applied mathematicians in the world who can do that, you're probably going to make mistakes. So this one I just threw in here for fun, more or less. EMV, so the chip cards that have been in credit cards around the world forever and finally are now showing up in credit cards in the US. They have a whole number of different keys in that chip. And those smart cards, which is basically what that is, and then EMV is a specific standard that uses a smart card, traditionally have been engineered to be extremely robust against attacks of all sorts. Basically, the assumption is every user of a smart card is an enemy because there's no control over what they can do with it. So, you know, they've been engineered to protect against differential power analysis and whatnot. So, fairly strong hardware token by itself. And so MasterCard and then Visa hopped on that bandwagon, came up with a solution to actually generate tokens based on the crypto that's already on the chip and use that for authentication in sessions. And then the Germans did something specifically where they allow you to, for a given transaction to another person's bank account, they will actually calculate a sort of signature based on the receiver's bank account number and the amount that's to be transferred. And then you have a little smart card reader, handheld smart card reader, that shows you that and says, hey, destination amount, is that really what you want? Then please press here or enter your PIN or whatever, and I'll give you this one-time token to use to confirm this transaction. And that way, actually, the user can't even deny anymore that they authorized that. There's other funny solutions, funny as in interesting. You know, we generate like a little pictogram on your web screen that you can then read into this device, and it does the same thing. It shows you details about the transaction, and you can confirm or deny it. Unfortunately, if you want to do that, then you need to be in the position to have the other side of the key material. So not everybody can just go and use EMV cards in their corporate infrastructure, right? If you haven't issued the card, you don't know what the key material is on the card. But I thought it was worth mentioning. So we've talked a lot about security and different threat scenarios. Just for completeness, I wanted to mention a few criteria as well that aren't directly security related, but that you probably want to think about when implementing solutions. And that just goes back to general infrastructure, architecture, etc. And I wouldn't call myself an expert in it, but I thought I'd point at least out what came to my mind while looking at all these solutions. So there's the whole question, how much does it cost in terms of operating expenses versus one time I buy an appliance and I'm done, or do I need to buy tokens, or do I need to pay for a license per user every year? Something to think about. Entrust had this nice little graphic here with all the different types of tokens they support in their solution. That's why I threw that in here. Open source, are there open source solutions? I haven't seen that many except for, so obviously the simple software implementation of one-time password tokens. You can just go and implement the RFC if you want. It's fairly straightforward, or there's, I'm sure, lots of people who do that and you can reuse it. Apart from that, I saw some freemium solutions, actually a lot, where the idea is, well, in a consumer context, you can use it for free, but if you want these extra corporate features, central management, etc., then again, we're back to paying money for it. Not unexpected, I think. Integration with identity and access management solutions, IAM solutions. So again, that goes back to the aspect of, I somehow need to associate tokens or biometric properties or whatever factor I have there, passwords, with a user in my system. And I need to manage that, and I need to be able to reset passwords and reissue tokens, and well, with biometrics you have a problem. All those things. So interoperability, that's something that both Josh and Kevin in their sessions earlier picked up on when they were talking about awareness of what's going on in your network. You want to make sure that whatever existing solutions you have or planning on implementing potentially in the future, you have the APIs in place, et cetera, that you need to actually talk to your solutions, the solutions to talk with each other, those kind of questions. How does it integrate? So there's I wanted to point out there's an open source framework for IAM called Glue that's actually based out of Austin here. There's another one called OpenAM that seems to be fairly mature. And they do it's open source, but then if you want to buy our implementation support, et cetera, then you pay for that. There's a lot of commercial solutions. SailPoint is also located here in Austin. There's tons of them. We had some other pictures and slides earlier. I make the slides available too. You don't need to take notes. Should have pointed that out earlier. Usability. Probably there aren't many end users that want to carry half a dozen of these tokens on their keychain. So the whole aspect of finding the right middle between imposing additional burdens on users by making them use an additional factor versus the gain you get out of it, and how can you make that as smooth as you can and at least burdensome for the user. So efficiency, availability, is it convenient, is it not? Definitely something to think about. If it's not convenient, then users will try to find a way to circumvent it. Just general architecture thoughts, some more. Are we okay with installing clients on our endpoints? Does that gain us anything? Do we want a solution that, maybe it's all web-based and we just need to change our form for log on and we're done? I don't know. Do we want smartphone apps or not? Is it a cloud-based service? Or do we want an appliance in our infrastructure? All those typical questions. Again, interoperability, APIs, logging, existing authorization infrastructures, radius as a typical traditional examples. Think about what you need and what you might need in the future and look for solutions that fit the bill. Availability of the solution itself. If the solution goes down or the enforcement server side of the authentication solution isn't available, does that mean your users can't log on anymore? It's a question. Does it scale? Does it scale to what you think your consumer numbers might be in a year from now or 2 years? Is the company that you're getting the solution from able to provide support, bug fixes, security fixes? What's their reputation? What's their history? Those kind of questions. Can you actually put SLAs in place to guarantee availability of cloud-based services? Can you put redundant systems into your data center if you host them yourself? And what do you do if the internet goes down? Can users not log on to your servers anymore? I don't know. So additional things to consider here. So I know that in the original title of my presentation, I promised you snake oil, more or less. I inferred there would be some. I didn't really find anything that I would plainly label snake oil, but I looked around a little bit. How do you find snake oil? So either you just run into it, or you search for it, you Google for it. And actually, the OWASP Guide to Cryptography, which, authentication is based on cryptography, whatever. What they have to say about snake oil, they say, typically advertisement for solutions advertises a breakthrough in cryptography and being unbreakable and the best and providing military-grade security. And those are good indicators that really there's a lot of marketing going on and maybe not much behind it. So I Googled. I Googled for strongest, secure, safe, unbreakable authentication. The first two that came up were advice on how to come up with good passwords. The fifth was actually the Guide to Cryptography. That's how I found it. The third was EduLock, a two-factor authentication solution for schools. And I was like, oh, I'm going to look at this. So on their website, they promise you unbreakable security, unbreakable technology, patented solutions that are impenetrable. And I was like, oh, interesting. I wonder what they actually do. So I looked at all the public information on their website, et cetera, and tried to understand what's going on. And basically what they do is you provision tokens to users, and it can be a smart card, it can be a soft token. You can plug in different ones there. And they are registered somehow with an authentication provider here. And then if they have a plugin, if a user tries to log into a web-based service or whatever service, then that service gets a token from the authentication provider if the user actually used his hardware token or whatnot to authenticate with it earlier. And so that way, two-factor, second factor that the service can rely on being enforced by this authentication provider. That's all fine. It's a solution that does something that works. The way they do deal with user provisioning is, if I understand it correctly, I may have gotten it wrong, they give everybody 3 cards, a card to use and then 2 backup cards that you can lock away somewhere if you lose one. And that way, it's user self-service. May not be snake oil. It probably isn't snake oil, but I thought it's a little bit weird. Basically, I have a specific patent I came up with, and now I'm going to implement that to be unique. But then I was like, well, so what do best-in-class solutions advertise? And I looked at the Gartner Magic Quadrant for 2013, and the best-in-class solution was SafeNet. And I looked at their website, and SafeNet, which has a suite of IAM solution and different tokens you can plug in and whatnot, authentication factors, market leader. That's the same thing. They say, well, the more factors used, the greater the trust of authenticity. Doesn't matter which kind of factors, the more is better, right? Obviously, if you use biometrics, then that is 3-factor authentication. And they have the most secure methods out there anyway. So, basically what I want to say here is, either way, you need to look behind the marketing blah and understand what's actually going on if you look for a solution. So, conclusions. Don't trust the marketing hype. We just talked about that. Don't just go and say, oh, everybody is using, well, maybe secure ID tokens are out, I don't know, but everybody's using the smartphone-based tokens now. I'll just go do that, and I'm going to be more secure. Maybe you will be, maybe not. You really need to understand what your exposure is and how to mitigate it, whether the solution you have in mind actually mitigates your exposure. Otherwise, it's just going to be, it looks nice on the compliance report, but really it doesn't do much good for your security. And then once you've thought about it from a security perspective, then you need to go the next step and actually think about, well, is it interoperable with what I have? Is it usable? Or maybe I'm going to make a compromise and use something that's more usable and a bit more risky. Depends on what you want to do, but think about it. Do a risk assessment before you settle on a solution. That's what I had to say. You can find me on the internet. Talk to me after the talk. Are there any questions?
Has your research provided you with any opinion on the FIDO Alliance?
Yeah, I haven't looked recently at it. I looked at it for a talk that I actually gave at the B-Sides conference here, the last B-Sides in Austin. What they try to do is to standardize the way that different types of tokens interact with different types of authentication enforcement points. And they do that by, if I remember correctly, you may want to go and double check, I might make stuff up. If I remember correctly, they do that by telling you how to do certain crypto channels, how to set those up, and you need to have this kind of key here on that end and this kind of key on that end. And that way you can plug in whatever tokens you want, and they all use the same channel mechanism. But that then has its own problem because everybody relies on whatever risks that introduces. So,
They just released the final standard for U2F, and Unicode has a token.
Yeah, and Google started accepting it. Yeah, so they implemented it. Yeah. Mm-hmm. Other questions? Cool. All right. Well, I hope there's dessert left, and you enjoy the rest of your conference.